Hi, Anthony Carruthers, Better Lesson, Master Teacher Project. And in this video, I'm going to discuss how I show students how to derive the equation of a parabola. So at the beginning, the most important thing for me is just to give students a good visual orientation to the situation. So I graph the directrix, y equals 3, graph the focus, negative 4, 7, place an arbitrary point P on the parabola, give it coordinates x, y, and at this point, I want to reinforce the definition of the parabola, which means that the distance from this P to the focus has to be the same as the perpendicular distance from P to the directrix. Okay, I've labeled A that point of intersection. The next point I want to make is that segment PA is a vertical segment because it's perpendicular to the directrix, which is horizontal. Therefore, P and A should have the same x coordinates, so whatever this number is, this will be the exact same number, so that's why they both say x. The y coordinates will be different, so whereas P has y coordinate y, A will have a y coordinate of 3 because any point that's on the directrix must have a y coordinate of 3. Moving on from there, now that we've introduced F, P, and A into language, we can say that the distance from F to P, so from focus to point on the parabola, is the same as the distance from point on the parabola to point on the directrix. Expressing that algebraically, we can use the distance formula to find the distance between F and P. We don't need the distance formula to find the distance from P to A. Some students will want to know why. PA being a vertical segment has the same x coordinates for P and for A. Therefore, to find the length of segment PA, we can just subtract the y coordinates and find the absolute value of that difference. Okay. Y being the larger of the two values, I really don't need the absolute value, so I can just express it this way. And then to get rid of the radical, students need to know that we're going to square both sides. So the y minus 3 becomes y minus 3 squared. And at this point, I just advise students that we're not going to touch the x plus 4 squared. They'll see why later when we talk about vertex form, but for right now, just say in terms of the form that we want to get this in, we'll leave the x plus 4 squared alone, don't touch it. Okay, but they do square the other binomials, which they've had experience with, and I just instruct them to get the y by itself. So eventually we get down to 1/8 times the quantity x plus 4 squared plus 5 equals y, which we just turn around so that the y is on the left. And we get this, the vertex form of the parabola. So I tell them that from this, I can actually see the vertex of the parabola is at negative 4 and 5. The negative 4 coming from this part here, and the 5 coming from this part. And then graphically, we'll want to see why negative 4, 5 actually makes sense. So I will come back up here and say that if the focus is at negative 4, 7, and the point on the directrix directly below the focus has to have the same x coordinate, so it also have x coordinate negative 4, and it have to have y coordinate 3, that means that that point will be at negative 4, 3. I know that the point on the parabola has to be the same distance from the focus and the directrix, so it would have to have negative 4 for the x coordinate, and the y coordinate would have to be halfway between 3 and 7. And we know that that number that satisfies that is a 5. So then it makes sense that the vertex will be at negative 4, 5, which is what the vertex form of the parabola tells us. So these are just some of the elements that I put into my demonstration for students in showing how to derive the equation of a parabola. I hope it's been helpful. Once again, I'm Anthony Carruthers, Master Teacher Project with Better Lesson.